Hello everyone, this is Mr. 13 Things, or Silence Did Good, depending on which channel I choose to upload to. Mostly Silence Did Good these days, and what we're going to do is we're going to look one more time at this kind of very abstracted way of using a quaternion rotation on a point, but now instead of using one point, we're going to have a set of points, or a larger set, and then take a subset and just do the quaternion rotation on it. So if you look back to the last video, I'm going to review, hopefully you saw that, but what we're doing is we're using basically a transformation. So a point is defined by a vector in SketchUp, or pretty much a point is a vector. If you want to think about it this way, a point is the end of a pointer. A point is the end of a pointer that emerges from the 0, 0, 0 in 3D space, or from the 0, 0, or something known as the origin in any defined coordinate plane. And so we'll go through quickly again. This is inside of SketchUp. We're looking at the Ruby code editor. I think it's Jim Foltz probably did this one. There's a few of them out there, but now they've been kind of brought underneath the whole SketchUp. Even the free version or the paid version, the great SketchUp Pro, on sale for Christmas. They have something called development tools in there, and this kind of Ruby code editor is in there. So let me explain what's happening in this code again. So we have defining the model, we're calling it model, defining the entities. Those are the individual things, if you would, inside of SketchUp. Faces, and if you want to think of it at the starting point, it's faces defined by edges, defined by points. So and the way the data is kind of laid out that way. We then have this kind of variable called selection that's going to be used to store our particular selection. You could have more than one selection, giving it different names inside of a database as you're trying to manipulate and group different things. We then have just these perfunctory, I'm going to say there's 1, 2, 3, 4, 5, there's probably about 2 more that you probably much want to put into every single Ruby you do. There's some more that should go on top of that when we start talking about putting these things inside of something called classes. We'll include that. That said, we now then define, and I want to also point out, you want to always be aware before you start in any SketchUp that in fact your model is laid out so you understand what coordinate system you're in. Excuse me. SketchUp actually does something. It can geolocate your model. This one is not, but basically the units you want to understand. And if you're troubleshooting, I would really tell you it's best to put it in decimal inches, which is really weird, but the inch is the base unit inside of SketchUp. 1999 out of a company called Lasser Software, a bunch of cool architects, but did everything in inches. All right, so that said, we're now defining 1, 2, 3 points. Construction points, which is by the add underscore C point. So this is basically an object, which is entities, and it's being acted on with a function called add construction point with one parameter. So this is inside of each parameter there are 3 parameters, but this is basically the points 1, 2, 3 on the number line, if you would, as you're walking along the x-axis. We then define a list. And you're going to see that's a kind of really key structure. The difference between lists and either dictionaries or hashes is small for now, but it will be big later. But we're defining a list. The list is going to then allow us to stick these construction points, which we have already defined, inside that list, as we do that with this. It's also typically, you can see the command .push is the same as that. So I guess I'll do this. I'll put .push. And you can see that will still work. So this is 2 ways to do the same thing. This is, sometimes someone might see that as a bit shift, but what we're doing is we're forcing this onto the end of the list. We're appending is the term, and this does the same thing. So we have 3 points in the list. Now we're going to add that list of points to a variable called, we're going to add it to this variable called selection. So selection is going to be that list inside. What you'll see later is we can add more things to selection, and we can deselect things. But what we've done is we now have a selection set, if you would. That's the AutoCAD speak, or basically it's good speak for lists as well, a selection set of 3 points. We then add to the model 2 more points just so we can see they're not going to be manipulated, but we're going to add them. So we're going to be basically hopefully only acting on 3 points. We could, if we wanted to, add another thing here that added each of these to a different list, but we won't. Going down here, you've seen this code before. It's a little bit long-winded, but what we've done is we've defined both an angle in the XY plane for our axis of rotation and then an angle of rotation about that axis. And we've put them in radians. We now have a extra thing here which we don't need, so we're going to get rid of that. We define a transformation, and this is what the original discussion was. This essentially is the closest we have to a quaternion. The math appears to be quaternion math, but the inputs then become a little bit more straightforward. They're just the origin point of the rotation, a vector describing the direction of the angle of rotation, and then the angle of rotation. Again, everything has to be in radians. And this, in fact, this is actually the components of a unit vector. We then transform the entities, and I show it 2 ways here. You can do it this way, and this we're going to once again antic on the entities. We're transforming them with this transformation, and we're transforming these entities, the ones that are in PT list. Probably a better way to do that, however, is that's a comment in Ruby. I'm going to go ahead and do it this way so you get used to cycling through. I'm not going to say better in terms of a unit test, but in terms of understanding. We're saying this. For each thing in the selection, we're going to call it inside the loop, we're going to call each of those entities E, and then we're going to transform each entity E as it loops through with the transformation trans. And we're going to run that, see what it looks like. Excuse me. I'm going to hit right there, and you can see those 3 points were transformed, and these 2 were not. So you can start to understand why the concept of abstraction, there's a lot more going on here, but eventually when you clean this code down, right, it can be even shorter than it is, and it's doing a lot more than just one rotation. So we're doing this in comparison to the hand calculations of a quaternion, so we can start teaching why we might want to start teaching kids to abstract a little bit more. And essentially that's what we're doing when we teach them to use calculators. Once they understand what 2 times 3 means, we show them that 2 times 3 in a calculator. You're kind of giving away understanding what's going on for the short term. How we deal with that in testing in a world, my kids will be out of this system before you all figure this out. But this, in fact, is why things like Coder Dojo and things like what's happening in Estonia, there is an understanding that the computational power of the planet and what everyone is going to have access to, even in developing countries, needs to be addressed not by completely redoing our math curriculum, but by thinking about how computer science is brought into it. And that's why one of the most exciting things people still aren't talking about and what's being thought about at Mathematica out of Champaign, Illinois with Thomas Wolfram, but that's another day. What we're looking at here is Ruby code. We'll also look at the Khan Academy computer science framework and do much of the same thing. Thanks for listening.